Hi all, welcome to another video of the subject Power System Analysis based on KTU syllabus, and we are on module 2, and in the previous videos we have discussed the unsymmetrical faults on power system through impedance in single line to ground fault and line to line fault, and in this video we are going to discuss the double line to ground fault power system through impedance. So the corresponding representation of the figure is like this. So all the three phases are represented using three steps here, and here the phase B and phase C are shorted, and it is connected to ground through an impedance ZF. Okay, so from the figure itself, some assumptions can be made, that is IA is equal to 0 and VB is equal to VC is equal to VB is equal to VC, and it is equal to this ZF into IF. That is, IF is a fault current flowing through that impedance. So ZF into IF, where IF will be IB plus IC. Okay, so these are the assumptions you can see here, and from the matrix equation of the line currents we obtain the equation. This is the matrix equation that we know. From that we obtain IA is equal to IA0 plus IA1 plus IA2. Okay, and we know the value of IA equal to 0, so the sum of the symmetrical component IA0 plus IA1 plus IA2 will be equal to 0, and IA0 we will obtain it as minus of IA1 plus IA2. And from row 2 and row 3, that is IB and IC, okay, IB and IC, we will get IB is equal to IA0 plus A square IA1 plus A IA2, and IC is equal to IA0 plus A IA1 plus A square IA2. And if you are just adding these two equations, IB plus IC, at last we obtain 2 IA0 plus A square plus A IA1 plus A square plus A IA2. Okay, and also we know that the 1 plus A square is 0. Okay, so instead of this A plus A square, we will get a substitution like minus 1. Okay, so in the above equation, that is IB plus IC, instead of this A square plus A, just substitute minus 1, so that we will get 2IA0 minus IA1 minus IA2. Okay, so 2IA0 minus of IA1 plus IA2, IB plus IC will be equal to 2IA0 minus of IA1 plus IA2. Okay, and we know that IA1, what is IA1 plus IA2? Okay, IA1 plus IA2. Here IA0 is equal to minus of IA1 plus IA2. So IA1 plus IA2 will be equal to minus of IA0. Okay, so instead of this IA1 plus IA2, we are going to substitute the value of minus IA0 here. So here just substitute minus IA0, so that we will obtain the sum of the currents IB plus IC is 3IA0, which is the fault current IF. Okay, IF. So IF is IB plus IC, and it is equal to 3 into IA0. Okay, so there we know. And from the voltage equations, we know that VC is equal to VB. Okay, so in the symmetrical components of the voltage, the equation is like this, and instead of this VC, substitute VB. Okay, and VA0, by solving this matrix we will get VA0 as 1 by 3 into VA plus VB, that is equal to 1 by 3 into VA plus 2VB, and the equations for VA1 and VA2 will be same, because the terms are VB and VB. Okay, so we can write it as VA1 is equal to VA2 is equal to 1 by 3 into VA plus AVB plus A square VB. Okay, and if you are taking outside that VB, so we will obtain 1 by 3 into VA plus A square into VB, and A plus A square we know that it is minus 1. Okay, previously we have shown that A plus A square is minus 1. So we will get, instead of this A plus A square, just substitute minus 1, and we will get VA1 is equal to 1 by 3 into VA minus VB. Okay, and just subtract this VA1 from VA0. So VA0 minus VA1 is equal to, okay, 1 by 3 into VA plus 2 VB minus 1 by 3 into VA plus VB. Okay, from that we will obtain VA0 minus VA1 is equal to VB. All other terms will be cancelled. Okay, and VA0 minus VA1 is equal to VB. Okay, and we know that the value of, what is the value of VB in the previous slides? Okay, the VB is equal to ZF into IB plus IC. That is equation 4.98, ZF into IB plus IC. So just substitute that value here. Instead of this VB, we have substitute ZF into IB plus IC. Okay. And also we know that the value of IB plus IC, that is a fault current, will be IB plus IC is equal to 3 into IA0. 3 into IA0. Okay. So just substitute the value of 3 into IA0 instead of this IB plus IC here. So we will obtain VA0 minus VA1 is equal to ZF into 3 into IA0. Okay. Which means VA0 is equal to VA1 plus 3 ZF I0. And also VA0 we can write as VA2 plus 3 ZF IA0. Okay. Because VA1 is equal to VA2. Okay. From the matrix equation, this matrix equation, VA1 and VA2 are same. Okay. So VA0 is equal to VA1 plus 3 ZF IA0. VA0 equal to 3 VA2 plus 3 ZF IA0. Okay. So from these equations we'll obtain as, okay, that is the zero sequence voltage component VA0. Okay. VA0 is a sum of positive sequence component plus 3 ZF IA0. Also it is sum of negative sequence component VA2 plus 3 ZF IA0. So it shows a connection like this. Okay. That is VA0. Here it is the VA0. VA0 is the sum of VA1. This is the VA1 positive sequence and this is the negative sequence voltage and this is the zero sequence voltage. So VA0 is sum of VA1 plus 3 ZF into IA0. Also we can write as VA0 is a sum of VA2 plus 3 ZF into IA0. So these are connected in parallel. Okay. So this is the corresponding representation. Okay, that is the sequence network of a double line to ground fault through an impedance ZF. And from this equation we can write the value of IA1. Okay, the value of IA1 we can write here. IA1 will be equal to VPF. This is the voltage here, VPF divided by all the impedances. Okay, so we can write it as here from the figure itself you can see that is Z0 and 3 ZF are in series. Z0 plus 3 ZF. Equivalent resistance will be Z0 plus 3 ZF. And it is again in parallel with Z2. Okay. So this network is in parallel with Z2 and the equivalent impedance again is in series with Z1. Okay. So just note down the points. Here the equivalent resistance is Z0 plus 3 ZF. Okay. And the equivalent, this is in parallel with Z2. So the corresponding representation, okay, that is the corresponding okay, equivalent impedance will be here. Okay, the equivalent impedance of this network we can write it as, that is Z2. Okay, this is Z2. Okay, this is in parallel with the equivalent resistance of this network. So Z2 into Z0 plus 3 ZF. Okay, 3 ZF divided by Z2 plus Z0 plus 3 ZF. Okay, like that we can write. Okay, that is in series with Z1. So we get IA1 as VPF divided by Z1 plus Z2 and the network is in parallel. So Z2 into Z0 plus 3 ZF by Z2 plus Z0 plus 3 ZF. Okay. So this is the equation, and also we will get VA1 as, okay, what is the equation for VA1? VA1 is VPF minus Z1 into IA1. And what is the value of VA2? This VA2 and VA1 are equal. Okay, so the same equation we can write VA2 and VA1 are equal. And also the value of IA2. Okay, IA2 will be VA2 by Z2. And the value of IA0 will be minus of IA1 plus IA2. IA1 and IA2 is flowing like this. IA0 is in this direction. So IA0 will be minus of IA1 plus IA2. Okay. So that is the equations here, and the fault current IF will be equal to IB plus IC 3 into IA0. Okay. I hope the expression is clear. So thank you.